Hi students, welcome to today's class. Today I am going to introduce a very important topic, and it is a fundamental concept of calculus and the beginning concept of calculus, a very important branch of mathematics, that is limits. Limit of what? Limit of a function. Already we know that what is a function. Okay now. So limit of a function. What is the, for everything in our day-to-day life also, we will have some limits. So whether for our either food purpose or whatever may be that purpose, we will have some limits. For that function also, what is a limit of a function? So if we understand the limit of a function clearly, then we can understand the differentiability of a function. After that, what is integrability of a function, definite integral, indefinite integrals, everything we know. For all the things, whatever maybe that we are going to learn in future, the limit of a function is a very basic concept. Okay, now let us start our class with what is limit of a function. Let us take a function f from set of real numbers to real numbers, and if it is defined as x square plus 3. Let us take x square plus 3 is a function. So the domain is a set of real numbers and the codomain is also a set of real numbers. Okay, now, right. Now here x is called a variable, whereas 3 is a constant. That means, so if you give the input value in x, you will get output value. Understand? For every x, you will get output. So here from set real numbers to real numbers, for every x input we give to this x, we will get the output. Okay, now, for example, if I take a 2, this is equal to 2 square plus 3, as we got exactly 7. So this 7 is called functional value of f of x when x is equal to 2. 7 is called functional value. Now we are going to see, as x value, that is a variable that we are going to take, it approaches to 2. That means what? In the number line, so here it will be 2 will be there. At exactly 2, the functional value is 7. If x value is approaches to 2, if x value is approaches to, when I am saying approaches to, tends to, or nearby, if I am saying that, so there are two. Immediately you have to get two ideas. One idea is whether we approach x from left hand side, we can approach 2 from right hand side. So we can write, we write this, this x approaches to 2 from left hand side. That means what? X takes the values, x takes the values here 1.5, next 1.9, this is 1.999, this is 1.999. Then what is the behavior of, at exactly at x is equal to 2, the function value is 7. If x value approaches to 2, then what is the behavior of f of x? Then f of x approaches to which value? Okay, now. So this, when it is approaching to, no, this is notation. In notation, we denote it as x tends to 2 minus, in the power minus we will look at. Don't think that this is not minus 2. This 2 minus means we are approaching x value 2 from left hand side. Now let us take if x value approaches to right hand side. So this is equal to 2.5. So this is a 2.1. This is 2.01. 2.0001. So this is x approaches to 2 plus. We call it as x approaches to 2 plus. Understand? So it approaches to 2 minus, that is from right side. Then let us see the behavior of the function f of x is equal to x square plus 3 in a graphical way. In a graphical way, let us see the behavior of this function by drawing the graph f of x is equal to x square plus 3. Okay, now, so let us continue the topic. Hi students, welcome to the remaining topic. So here the function is from R to R, f of x is equal to x square plus 3. At exactly x is equal to 2, at exactly x is equal to 2, the f of 2 is equal to 7. That is exactly 2. So when exactly x is equal to 2, f of x takes the 7. Understand? That takes the 7 value. Now what we are going to see is as x value approaches to 2, x value approaches to 2, I explained what is the meaning of approaching x value 2. That means, so when x value approaches to 2, then one thing is clear, we can say that, so we can draw that there is a here. See here. So when x value approaches to 2, so your f of x value will also approaches to 2. Understand? See, approaches to 7 here. See here, as x value approaches to 2, then your f of x value also approaches to 2, 7. So for this, let us take this, I am clearly explaining here that graph. So this is a 2. When you are taking the x values from left side of 2, so all your values will be 2 minus h. 2 minus something less than 1.99, 1.99 like some sort, 2 minus h. If you are taking the x values which are lies from the right side, these values are 2 plus h. 2 plus h. That means what? Here h is called infinitesimal. What is meant by infinitesimals means they are very small values. That means you can take h value x to the power of 10 to the power of minus 25. That means what? That is equal to 1 by 10 to the power of 25. 0.00025 zeros 1. That means see how much less value that we are taking. So these are called infinitesimal values. So here we are very small values we are taking. Okay now. So that means limit x, this we call it as a in notation, limit as x value approaches to some 7, x value approaches to 7, approaches to 2, this f of x value approaches to 7. F of x means here x square plus 3 value, it approaches to 7. Understand here? Now in notation, how to denote this? Let us take some x value approaches to x tends to a plus f of x is equal to, then we write it as a f of a. Now let us take here a as a 2 minus h. That means what? H tends to 0 as x tends to a plus, here a is equal to how much you are taking? 2 minus h. So x is equal to 2 minus h. As x value approaches to some 0 or any 2, as x value approaches to 2, h value approaches to 0. As h value approaches to 2, x value approaches to 2. That means in place of x tends to 2, we can put h tends to h minus, as h tends to, in place of x tends to 2 minus, we can substitute h tends to 0. Okay na? Then in place of wherever x is there, in place of that we can substitute 2 minus h. Okay, let us see how this notation will appear. Okay now, welcome back here. Two cases arises. As x value tends to 2 minus, that means x is equal to, we can take here, so already we wrote here, this is a 2 minus h, that side 2 plus h. So x is equal to 2 minus h. As h value tends to 0, x value approaches to 2. As h value approaches to 2, x value approaches to 2. Okay now our notation is limit x tends to 2 minus f of x is same as, f of x means how much here? X square plus 3. So this can be written as x tends to 2 minus, as x value approaches to 2 minus, h value approaches to 0. So in place of x, we substitute 2 minus h. 2 minus h whole square plus 3. 2 minus h whole square plus 3. Now let us see that. So here this is equal to limit h tends to 0. So this is a 4 minus 4h plus h square plus 3. So this is a limit h tends to 0, 4 plus 3 7 minus 4 of h minus h. Otherwise you can take a plus h into 4 minus h. Otherwise h minus 4. h minus 4. Okay na? h minus 4. We know that as h tends to 0, h tends to 0, h of h minus 4 value approaches to 0. As h value approaches to 0, h tends to 0, this is h, this fraction approaches to minus 4, 0 into minus 4, 0. Therefore, so here we will get 7. This limit is called, as we are approaching x value from left hand side, as we are approaching x value from left hand side, we call it as a left hand side limit, LHL, left hand side limit. So if you want to find out left hand side limit, in place of x substitute 2 minus h. 2 minus h how to substitute a minus h. Okay now. So this is called left hand side limit. Similarly, we can find out the right hand side limit. Okay now. So let us continue the calculation. Let us see the second case, case 2. That here, second case means what? X value approaches to 2 plus. X value approaches to 2 plus. That means what here? X is equal to 2 plus h. X is equal to 2 plus. We are approaching from right side. That means as x value approaches to 0, h value approaches, sorry, x as x h value approaches to 2, x value approaches to 2 plus. Understand? Now we have to find out the behavior of the function x square plus 3. We have to find out the behavior of the function x square plus 3 as x value approaches to 2 plus. Understand? So this is equal to, as x tends to 2 plus is same as h tends to 0. h tends to 0. In place of x, we write down 2 plus h whole square plus 3. 2 plus h whole square plus 3. Now clearly this is a h tends to 0. 2 square 4, 4 plus 3, 7 plus 4h plus h square. Clearly as h value approaches to 0, 4h value approaches to 0, h square will is also approaches to 0, then its value is 7. That means what? This is called right hand side limit. That is called right hand side limit. That means left hand side limit, that means limit x tends to 2 minus f of x value also 7 we got. Right hand side limit value, limit x tends to 2 plus f of x is also we got 7. Limit x tends to 2 plus f of x is equal to also we got 7. Both left hand side limit is equal to right hand side limit. Therefore, limit x tends to 2, f of x is equal to 7. This is the notation. Okay now. So this whole theoretical part we will keep it in a formula, box formula. So let us see that box formula. Okay now. Now I am going to explain a very fundamental concept, that is left hand side limit. Limit x tends to a minus f of x. Limit x tends to a minus f of x. That means, so there is a function here x is equal to a. We are approaching from left hand side, that is x tends to a minus. This notation is same as limit h tends to 0, f of a minus h. Limit h tends to 0, f of a minus h. In place of x, we will substitute a minus h, 2 minus h. As h tends to 0, x tends to 2 minus, there we substituted 2 minus h, no? So here also a minus h. So limit x tends to a minus f of x is same as limit h tends to 0, f of a minus h. Coming to right hand side limit, so limit x tends to a plus f of x. That means when you are approaching the x is a value from right side, so that is denoted as x tends to a plus f of x. This is same as limit h tends to 0, f of a plus h. So this is a very basic fundamental formula. So here onwards, x tends to a minus means h tends to 0, f of in place of x. Here a minus, how to remember? A minus, here a minus will come, plus h will come. Here a plus, no, a plus. Here a plus h will come, understand? So this is a way of remembering, just remembering that, sir. Here a minus will be there, a minus h will come. Here a plus h will come, okay now, right? Using this notation, now let us solve the problem. Is limit x tends to 0 mod x by x, limit x tends to 0 mod x by x is equal to, is limit exist? Right, everybody will say that the limit does not exist. Generally students will start doing like this. So that means x approaches to 0 minus x less than 0, mod x is less than 0. Therefore limit x tends to 0, mod x means how much? Mod x is equal to minus x. So that is equal to minus x by x, x will cancel, minus 1. As x tends to 0 plus, so x greater than 0, mod x is equal to x. So limit x tends to 0, x by x, x will cancel 1. So left hand side limit is 1, right hand side limit is left hand side limit is minus 1, right hand side limit is 1. Therefore, so the limit does not exist. So this way is also one method of solving the problem. But actually the perfect way of solving is taking as h as a infinitesimal, okay? So now I am going to explain how to find the limit of the function mod x by x as x tends to 0, a perfect genuine method, okay now? So let us see that method. Hi students, welcome to this problem. So I am going to explain a very perfect genuine method of solving this problem. So if you do this method, definitely the examiner will appreciate a lot, okay, those who are writing board examinations. Of course, in if it comes as a problem for in a objective type, so if you put the answer does not exist, the answer will be over. But if it is given in a descriptive way, so if you solve the problem which I am going to explain, so you definitely, the examiner and the teacher will appreciate you a lot, okay. So let us see that method. So case 1. So we are going to find out left hand side limit. That means what? X tends to 0 minus, x tends to 0 minus. So therefore left hand side limit x tends to 0 minus mod x by x is same as limit h tends to 0 modulus of what I told there, what we thought, a minus, so if x tends to a minus, so once again I am telling, so limit x tends to a minus f of x is same as limit h tends to 0 f of a minus h. Here in place of a, 0 is there, h tends to 0, so this is equal to 0 minus h by h, 0 minus h by, in place of x, 0 minus h you have to write down, in place of x, wherever x is there you have to substitute 0 minus h. Okay, now, so this is equal to limit h tends to 0, 0 minus h, modulus of minus h, we know that h, by minus h, we can take minus common outside, limit h tends to 0, h will be cancelled, you will get minus 1. Okay now, right. Right hand side limit, that is a case 2. Limit x tends to, x approaches to 0 plus, that is a right hand side limit is equal to limit x tends to 0 plus. So here what is a limit x tends to 0 plus, f of x is equal to limit x tends to a plus, h tends to 0, f of a plus h, f of a plus, that is a minus h, it is a plus h. So here also we will get this is f of 0 plus h by 0 plus h, this is called modulus of limit x tends to 0, limit h tends to 0, this is a limit h tends to 0, here also h tends to 0, modulus of h value is h, upon h will cancel 1. So here the limit, left hand side limit is equal to minus 1, the right hand side limit is equal to plus 1. So where the left hand side limits and right hand side limit both are not equal, Therefore, at x is equal to 0, the function does not have any limit value. Therefore, we can conclude LHL is not equal to RHL. Limit extends to 0, f of x by x does not exist. This value does not exist. Okay, now. So, this is the actual correct method of solving the problem. So, if you solve this problem by taking h as an infinitesimal, every examiner will be appreciates. So, there are certain problems are there which you have to solve the problem like this method only. Okay, now. So, let us see one more example, very typical example. Generally, majority of the students, they will do mistake in this problem. Okay, so but don't do that, you say mistake yourself. Okay, so let us see that problem. Welcome to this problem. So, this is the problem majority of the students will do wrong. Okay, now. So, if you go in a vague method, general, what is meant by vague method? Limit extends to 0 minus, that means x value approaches, the variable values approaches 0 from left hand side, then what is the function value of the given function? Generally, students will start doing like this. X tends to 0, they will start substituting 0 here. 0 square minus 3 into 0, 0, 0 plus 2, 2, 0 plus 2, it is a 2. So, divided by 0 cube minus 2 into 0, that is equal to 0, 2 by 0, therefore, it is infinity. Infinity. So, the approaches to infinity, some students they will write it approaches to infinity, and some students they will write does not exist also they will write. Okay, na? But don't do the mistake. So, the correct procedure is taking infinitesimals. Okay, so limit h tends to 0 minus is same as, sorry, limit x tends to 0 minus is same as h tends to 0, so that this 0 minus 0 plus that will be avoided. In place of x, what I write down? 0 minus h, that means a minus h. Here if a minus is there, a minus h. If a plus is there, a plus h will come. 0 minus h whole square minus 3 into 0 minus h plus 2 by, this is a 0 minus h whole cube minus 2 into 0 minus h. So, this is the value that we are, that the required answer. Okay, now. So, let us see this. So, this is a limit h tends to 0. Therefore, there is no question of 0 plus or 0 minus, whether it is approaching right side or left side, nothing doing. Okay, now. So, let us do this problem. So, this is equal to h square minus into minus plus 3h plus 2 by denominator 0 minus h cube. This is equal to minus h cube plus minus into minus plus 2h is there. Understand this. So, minus h minus, sorry, this is a minus 2x square. So, this is a minus 2x square, this is also x square. So, this is equal to minus 2h you will get. Minus 2h you will get. Okay, now. So, in the denominator take minus limit h tends to 0, h square plus 3h plus 2 by h cube plus 2h. h cube plus 2h. Now, see the problem. As h value approaches to 0, as h value approaches to 0, numerator value approaches to 2. Numerator value approaches to 2. As h value approaches to 0, as h value approaches to 0, denominator value approaches to 0. Approaches to 0. So, on the whole, numerator is approaching to 2, denominator is approaching to 0. It is going on decreasing. Denominator is going on decreasing, approaches to 0. Okay. So, on the whole, this total function approaches to infinity. Total function approaches to infinity. Therefore, but here minus is there. So, this approaches to minus infinity. Understand? The answer is minus infinity, not plus infinity. So, if you think in a vague sense, you will get plus infinity. If you approach from the definition, it is called definition, fundamental definition. If you follow the fundamental definition, The answer is minus infinity. Okay now. So I hope that you understand this problem. Let us see one more this type of problem. Okay now. Hi students, welcome to this problem. Evaluate the left hand side limit and right hand side limit of the function defined as f of x is equal to 1 plus x square when x takes the values from 0 to 1. Of course, x is equal to 0 also there, and 2 minus x if x greater than 1. So why I am going to explain this method is, generally students will go in a vague sense. Okay now, so don't do that. So fundamentally you do. Okay, so solution. Left hand side limit. First of all, left hand side limit at x is equal to 1. That means what? X approaches to 1 minus left hand side limit I am going to find out. That means limit x tends to 1 minus f of x is same as limit h tends to 0 f of 1 minus h. Understand this? Limit x tends to, this is a left hand side limit. Limit x tends to 1 minus f of x is same as limit h tends to 0. 1 minus is there, no? Power minus is there, 1 minus h will come. 1 minus h will come. Now, when x approaches to 1 minus, x approaches to 1 minus means what? X less than 1. When x less than 1, how the function is defined? The function is defined as 1 plus x square. Therefore, limit h tends to 0. This 1 plus x square is equal to 1 plus, if f of x is equal to 1 plus x square, f of 1 minus h means wherever x is there, substitute 1 minus h. 1 minus h whole square. So this is a limit h tends to 0, 1 plus 1 minus h square. So this is equal to 1 minus 2h plus h square. It is clearly 2. Minus 2h plus h, that becomes 0, 1 plus 1, 2. So the left hand side limit is equal to 2. Okay, always you learn this method. Okay, the fundamental definition method. Okay. Now what is right hand side limit? RHL. That is a limit x tends to 1 plus f of x. Now we have to find out right hand side limit. That means x value approaches to 1 from right side. The notation is this. This is same as limit h tends to 0 f of 1 plus h. F of 1 plus h. So when x tends to 1 plus means what? X greater than 1. So answer is 2 minus x. So this is equal to 2 minus x means how much? 1 plus h. So this is equal to 2 minus 1, 1 minus h. This is equal to, sorry, limit h tends to 0. Here also limit h tends to 0. So this is equal to 1 minus h. This is equal to 1. So see here the left hand side. So when you are approaching the function from given x value from left hand side, the function approaches to 2. If you are approaching x value from right hand side, the function is approaching to 1. That means the function is not approaching to the same value. Then how can the limit exist? Therefore, the limit, that means limit x tends to 1 f of x does not exist. So this is the fundamental actual method of solving the problem. Okay. So let us see one more type of problem. Hi students, welcome to this problem. Let f of x is equal to cos of step x. This is a step x, greatest integer function. When x greater than or equal to 0, mod x plus a when x less than 0, x value less than 0. Find the value of a so that limit x tends to 0 f of x exists. Limit x tends to 0 f of x exists. That means what? At x is equal to 0, left hand side limit, right hand side limit x. Then find the value of a. We have to find the value of a if limit x tends to 0. That means what? When you are saying limit x tends to a 0 means left hand side limit is equal to right hand side limit. What is meant by left hand side limit means x tends to 0 minus f of x. This is a limit x tends to 0 plus f of x. Both limits are same. So don't take 0 minus 0 plus simply directly substituting there. No. So this is a, sometimes you will get some wrong result You will get some wrong results if you substitute there. There are certain problems are there. Directly if you substitute 0 minus here 0, here 0, no. So go for fundamental concepts. So limit x tends to 0 is same as h tends to 0 f of 0 minus h. Limit h tends to 0 f of 0 plus h. Understand? So let me simplify this. So limit h tends to 0 f of minus h. Limit h tends to 0 f of h. Okay, now right. Left hand side limit means x less than 0. This condition you have to use, that is modulus of, in place of x, how much substitute? Minus h. Modulus of minus h plus a, of course here limit h tends to 0 is equal to limit h tends to 0 f of h, that means cos of step of h. Okay, now cos of step of h. So 0 plus h, actually 0 plus h. Okay, now right. So as modulus of h is equal to h plus a. So this is a modulus of h tends to 0 cos of step h. Understand? So as h tends to 0, h plus a value tends to a. As h value approaches to 0, so see here, and it is a 0. So if you are approaching, h value tends to 0, cos h, so step of h value, also approaches to 0, and therefore cos 0 approaches to 1. Therefore a is equal to 1 is your correct answer. I hope that you understand this solution. Hi students, welcome back to this very small problem. So limit x tends to a, f of x plus g of x is equal to 2. Limit x tends to a, f of x minus g of x is equal to 1. Then find the value of limit x tends to a, f of x into g of x. Now in the limits we have properties. So when limit x tends to a, f of x plus g of x, we have the properties of the limits. Limit x tends to a, f of x plus or minus g of x is same as limit x tends to a, f of x plus or minus limit x tends to a, g of x. Okay, now so we can take the limit to both the functions. So here also limit x tends to a, f of x plus limit x tends to a, g of x is equal to 2. Second one is limit x tends to a, f of x minus limit x tends to a, g of x is equal to 1. Understand? So we got the two equations here, one called as two equations. Let us add these two equations. We get 2 times f of x, limit x tends to a, f of x, that is equal to 3. So limit x tends to a, f of x is equal to 3 by 2 we got. And you subtract these two functions from one another, then these two will be get cancelled. So this is a limit 2 times x tends to a, g of x is equal to 1. Limit x tends to a, g of x is equal to 1 by 2. So now limit x tends to a, f of x into g of x is same as limit x tends to a, f of x into limit x tends to a, g of x. Limit x tends to a, f of x is equal to 3 by 2 into 1 by 2. This is equal to 3 by 4. That is the final answer. Very easy problem this is. Here we can apply directly. So here there is no need of taking infinitesimal. Okay, now. So I hope that you understand today's class and you enjoyed today's class. With some more basic fundamental concepts, tomorrow's class I will stand before you. So until then, all the best.